Okay, let's unpack this. You've probably been there, right? Chatting with an AI, maybe trying to get it to write some code, and it just,
Mhm.
well, it doesn't quite get what you want.
Yeah, it misunderstands or goes off on a tangent or gives you something kind of weird.
Exactly. So today, we're diving deep into how to fix that. We're talking prompt engineering.
It really is the secret sauce. Think of it like learning the AI's language, guiding it so it actually gives you the good stuff.
Hmm.
We're going to pull back the curtain a bit, look at how these big language models actually tick, what happens when you type something in, and importantly, how you can get way better at steering them.
Right. So our mission today, break down the core ideas of prompt engineering, give you a whole toolbox of techniques, share some surprising facts and best practices, basically help you unlock what these large language models can really do.
And the key thing for you listening, you'll walk away knowing how to get more precise, more creative, just, more useful results from AI.
Yeah, and you don't need a fancy degree for this stuff. The source material really emphasizes that anyone can write a prompt.
Totally. So to really get prompt engineering, we kind of need to start with how a large language model, an LLM, actually works.
Okay.
At its core, it's basically a prediction engine. You give it text, the prompt,
Right.
and it doesn't understand like we do. It just predicts the next most likely token.
Token, like a word.
Sort of. Could be
Hmm.
a whole word or just part of one. It bases that prediction on all the data it was trained on. Then it does it again and again, token by token, building the response.
Ah, okay. So prompt engineering is like deliberately crafting that input text,
It
designing
is,
it.
exactly. Designing high-quality prompts to guide the LLM towards the outputs you actually want.
And it's not just a one and done thing, is it? The research mentions it's iterative.
Oh, absolutely. It's all about tinkering.
Yeah.
You tweak the prompt, play with the length, refine the style, the structure, until you nail it.
Why does it matter so much, though?
Because bad prompts, they lead to, well, junk, ambiguous answers, inaccurate stuff. The model just can't give you anything meaningful.
Right.
But good prompts, they turn these LLMs into amazing tools for, well, tons of things. Summarizing text, pulling out specific info, answering questions, classifying things,
Feature
translating.
generation, too, right?
Oh, yeah, code generation, language translation, even complex reasoning.
And does the same prompt work everywhere, like for Gemini and GPT?
Not always. You often need to optimize prompts for specific models, whether it's Gemini, GPT, Claude, Gemma, Llama. They all have their little quirks.
Okay, so the takeaway here is you're going to learn how to actually talk to AI effectively, turn those frustrating chats into something productive.
Precisely. Getting outputs tailored exactly to what you need.
So it's not just the words we use in the prompt then, there's more to it.
Right. Effective prompt engineering also means messing with the model's configuration settings. Think of them as internal dials for the AI.
Okay, dials. What's the first one we should know about? Managing the output, maybe.
Yeah, the number of tokens to generate is usually where you start. It controls how long the output is.
More tokens, longer answer. Simple enough.
Well, yes, but more tokens also means more computation, more energy used, slower responses, and higher costs if you're paying per token.
Ah, okay. Costs. Good point.
And it's important to remember, this setting isn't about making the AI succinct. It just tells it when to stop predicting. That's really key for some advanced techniques like React, where you need it to stop cleanly after getting the info.
Makes sense. So once we've got the length sorted, how do we tweak the AI's personality? Like
Mhm.
make it factual or creative?
That's where sampling controls come in. This is where it gets really cool. LLMs don't just pick one word, right? They assign probabilities to tons of possible next tokens.
Okay.
Sampling decides which token gets chosen from all those possibilities. The big one is temperature.
The creativity dial, I've heard it called?
Yeah, exactly. Temperature of 0, totally deterministic. It always picks the single most probable token. Perfect for facts, math problems, stuff like that.
Got it.
As you turn the temperature up, you let it consider less likely tokens. So you get more diversity, more creativity,
Hmm.
sometimes unexpected stuff.
And if you crank it way up.
Yeah, then it can become almost random, like gibberish.
Okay, so temperature's the main dial. What about top K and top P? How do they fit in?
Think of top K like this. You give the AI a list of the most likely next tokens, say the top 10 or top 40, that's K, and you tell it only pick from this list.
So a smaller K means less choice.
Right. Top K of 1 is the same as temperature 0, basically. Just pick the very top one. Higher K means more options, more variety.
And top P, that sounds a bit more complex.
It is, slightly. Top P, or nucleus sampling, works with cumulative probability. It looks at the list of tokens, ordered by probability, and keeps adding them until their combined probability hits a certain threshold, p. Let's say p is 0.9 or 90%. It takes just enough of the top tokens to reach that 90% probability mass.
Ah, so it's selecting from a probabilistically significant set rather than just a fixed number like top K.
Exactly. It's a bit more dynamic.
So, how do they all work together if you have all three settings available?
It's usually a two-step process. First, top K and top P filter down that huge list of possibilities to a smaller set. Then, temperature does its sampling magic on that smaller filtered list.
Okay, filter, then sample.
Right, and they interact. Like we said, temperature makes top K and top P kind of pointless. The model picks the top token anyway.
And top K1 does the same thing.
Yep. If only one token makes it through the top K filter, temperature and top P don't have anything to do.
Okay, this is great. But for someone just starting, what are some sensible defaults? Where should you begin?
Good question. The source gives some solid starting points. For something coherent but still creative, try temperature 0.2, top P 0.95, top K 30.
Okay.
Need really creative stuff. Maybe temperature 0.9, top P 0.9, top K 40.
Whoa, high temp there.
Yeah. And for less creative, more factual, maybe temperature 0.1, top P 0.9, top K 20.
And for that math problem.
Always temperature 0.
Yeah.
Start there if there's a single right answer.
Got it. Now, something I've definitely hit is that horrible repetition loop bug, where the AI just repeats the same phrase.
Yes, it's super annoying.
Why does it happen?
Yeah.
And can these settings fix it?
It happens because the model, remember, is just predicting the most probable next token. Sometimes that most probable path just happens to loop back on itself, even if it sounds dumb to us.
So it gets stuck.
Exactly. And it can happen at both low and high temperatures, weirdly enough. Low temp can make it too rigid, locking into a pattern. High temp can make it so random it just happens to circle back.
So how do you fix it?
You tinker with these settings. Nudge the temperature up or down slightly, adjust top K or top P. You're basically trying to gently push the AI off that repetitive high probability path onto a more diverse, coherent one. It's about finding that sweet spot.
Okay, so understanding these dials helps you tune the AI's style, stop the weird loops, and even save money. That's pretty powerful. All right, let's get into the real meat, the prompting playbook, the techniques. What's rule number one?
Clarity. Absolutely rule number one. LLMs are instruction-following machines. The clearer, the more precise your prompt text, the better the results. Sounds basic, but people forget it.
Okay, be clear. And the simplest way to prompt is just ask. No examples needed.
Yep, that's general prompting, or often called zero shot. Zero examples. You just give it the task and the input.
Like classifying a movie review.
Exactly. You can say, classify this movie review as positive, neutral, or negative. Review. Paste review text here. Sentiment.
And you use that tricky her review example. Disturbing study, but also masterpiece.
Right. That's the challenge for the model. How does it weigh those conflicting signals? For something like classification, you usually want a low temperature. You want an objective label, not a creative interpretation.
Okay, so zero shot is the baseline. Adding examples must be better then.
Oh, massively better in many cases. Examples give the model concrete illustrations of what you mean, not just abstract instructions. They show it the structure you want, the tone, the pattern.
And that's one shot or few shot?
Right. One shot is a single example. Few shot is multiple, usually like 3 to 5 is a good rule of thumb, but maybe more for complex tasks, or fewer if you're hitting input length limits.
Like that pizza order example, parsing into JSON.
Perfect example. With a few examples showing how to handle regular orders and tricky stuff like half pepperoni, half mushroom, you teach the model the exact JSON format you need.
Makes sense. What makes a good example, though?
Good question. They need to be relevant, obviously. Diverse, cover different scenarios, high quality and well-written, no typos. Even small errors can confuse the model.
Right.
And critically, if you want robust output, include edge cases. Those weird, unexpected inputs. Teach the model how to handle them gracefully.
Build resilient prompts. I like that. Okay, what about giving the AI some direction, like setting the scene? System, contextual, role prompting?
Yeah, these are all ways to guide the AI's focus and identity, but they work slightly differently.
Okay. How does system prompting work?
Think of system prompting as setting the overall ground rules, the big picture purpose for the entire interaction. It defines fundamental capabilities.
Right.
Like, you are a helpful assistant that classifies movie reviews as positive, neutral, or negative. Only return the label in uppercase. Or, and this is a really useful one, instructing it to always return valid JSON.
Why JSON specifically?
Well, forcing JSON output is great because it gives you structured, predictable data. easy for other programs to read, and it actually helps reduce hallucinations. The AI tends to stick to the requested structure instead of making stuff up.
Ah, interesting. Okay, so system is the overall rules. What about role prompting? That sounds fun.
It is. Role prompting is giving the AI a specific character or persona to adopt. Act as a sarcastic pirate, or you are a supportive coach. This frames its entire style, voice, and tone.
Like the travel guide example, asking for tips in Amsterdam versus Manhattan with a humorous style.
Exactly. You'll get totally different outputs based on the role you assign. The research shows tons of styles work. Confrontational, descriptive, humorous, inspirational, you name it.
Okay, system rules, role a character. What's contextual prompting?
Contextual prompting is about providing specific, immediate background info for the current task or question. It gives the AI the necessary context right now.
Like the retro arcade games blog.
Perfect. Context. You are writing for a blog about retro 80s arcade video games. Suggest 3 topics. Because you provided that context, it suggests relevant topics like evolution of cabinet design or rise of pixel art, not just generic game ideas.
So distinguishing these helps you design better prompts.
Yeah, it gives you a clear mental framework for thinking about how you're guiding the AI at different levels.
Okay, now this next one sounds really powerful for getting better reasoning. Step back prompting.
It is. It's a clever technique. Instead of asking your specific question directly, you first prompt the LLM to answer a more general, related question. Then you take that general answer and feed it back into a second prompt that asked your original specific question, using the general answer as context.
Why do that?
It forces the AI to activate broader background knowledge and reasoning principles first. It thinks about the bigger picture before diving into specifics. This often leads to much more accurate, insightful, and less biased responses.
Can you give that video game example again?
Sure, you want a challenging FPS storyline. A direct prompt might be generic.
Right.
With step back, first you ask, suggest 5 fictional key settings for a challenging FPS game. It might give you abandoned military base, cyberpunk city, etc.
Okay, general ideas.
Then you pick one, say cyberpunk city, and use it in your main prompt. Context. The setting is a dark cyberpunk city. Generate a challenging storyline for an FPS game. The resulting storyline will be way richer and more tailored because it started from that broader conceptual base.
That's smart, like brainstorming first. Okay, building on thinking deeper, we have chain of thought or COTI, showing your work.
Exactly. COTI is fantastic for improving reasoning. You simply ask the model to generate the intermediate steps it takes to get to an answer. Think step by step is the classic phrase.
Low effort, big impact.
Often, yes. It works surprisingly well, even with off-the-shelf models. Big advantages are interpretability. You see how it got the answer, and it tends to make the model more robust across different versions.
Downside.
More tokens. It writes out all the steps, so it costs more and takes longer.
Makes sense. What about that tricky math problem? When I was 3, my partner was 3 times my age.
Ah, yes, the classic. A direct prompt often gets it wrong, maybe says 63.
Right.
But add, let's think step by step, and suddenly it lays it out. Okay, when you were 3, your partner was 3, creep is 9. The age difference is 9, 3 equals 6 years. Now you are 20. So your partner is 20 plus 6 equals 26 years old. It shows the logic.
Wow. Just adding that phrase unlocks the reasoning.
It's pretty amazing. And you can do few-shot COTI too. Give it an example. Problem with the reasoning steps already solved, then give it the new problem.
Where is CAR-T most useful?
Anywhere that benefits from breaking down a problem. Code generation, creating synthetic data, complex question answering. Basically anything you could solve by talking yourself through the steps.
Good tip. Always put the answer after the reasoning and use temperature 0 for single correct answer.
Absolutely. Key best practices for COTI.
Okay, what if you need consistency, especially on maybe a subjective task where there isn't one single right answer?
That's where self-consistency comes in handy. The idea here is to run the same prompt multiple times, but this time with a high temperature.
High temp, so you get different answers.
Exactly. You want diverse reasoning paths. You generate several different responses, each potentially reaching a different conclusion or using different logic. Then you look at all the final answers and pick the one that shows up most often, majority voting.
Ah, like getting a second, third, fourth opinion.
Precisely. It improves accuracy and coherence by considering multiple angles. It kind of gives you a pseudo probability of correctness. The downside, it's expensive. You run the prompt multiple times.
That Harry the Hacker email example seems perfect for this. The tone is tricky.
It is. Is it important or not important? The friendly tone and sarcasm can fool the LLM. One run might say important, another not important. Self-consistency looks at, say, 5 runs. If 4 say not important, you go with that. It leverages the wisdom of the crowd, even if the crowd is just the AI talking to itself differently each time.
Clever. Okay, quickly, tree of thoughts. Cody on steroids.
Kinda, yeah. Tree of thoughts, or TOTI, generalizes chain of thought. Instead of just one linear reasoning path, it allows the LLM to explore multiple paths simultaneously, like branches on a tree.
For really complex problems.
Exactly. Things that require exploring different possibilities before finding the best route.
And finally, the one that turns the AI into an agent. React.
React, reason, and act. This is super cool. It combines the LLM's reasoning with the ability to use external tools.
Tools like what?
Search engines, code interpreters, APIs, stuff like that. It mimics how we often work. Think about a problem, realize we need more info, go look it up, that's the act, then think again with the new info.
So it creates a loop. Thought, action, observation, thought.
Exactly. The LLM reasons, I need to find out X, plans an action. I should search Google for X, performs the action using a tool, observes the result, Google says Y, updates its reasoning based on Y, and plans the next step until it solves the problem.
Can you give that Metallica example? How many kids?
Sure. You ask, how many children do the band members of Metallica have?
Yeah.
Using something like LangChain to connect to tools, and maybe SERP API for Google search.
Okay.
React would first reason, I need the names of Metallica members. Action. Search for Metallica band members. Observation. Gets list. James Hetfield, Lars Ulrich, etc. Reasoning. Okay, now I need the number of children for James Hetfield. Action. Search James Hetfield children. Observation, gets number, it repeats this for each member, keeping track, and then finally reasons. Okay, I have the numbers for everyone, now I add them up. Action. Calculate sum. Observation. Final answer.
Wow, you can actually see it performing searches and updating its plan.
Yeah, the output often shows the thought, action, observation steps. It's incredibly powerful for tasks requiring real-world, up-to-date information or complex interactions.
So that's an amazing toolkit. You've got strategies for everything from simple questions to really complex problems, truly guiding the AI now.
Absolutely. And we can take it even further with some advanced strategies and best practices. Ever heard of automatic prompt engineering? APE.
Prompts writing prompts. That sounds meta. How does that work?
It is pretty meta. APE basically automates creating the prompts themselves. You prompt a model, say Model A, to generate a bunch of candidate prompts for a specific task you want Model B to perform.
Okay.
Then you test those generated prompts on Model B, evaluate how well they perform using metrics like BLEU or Rouge scores, which compare the output to a gold standard and select the best ones. It can massively speed up finding high-performing prompts, reducing the human effort.
Like generating variants for that band t-shirt chatbot example?
Exactly. You could ask Model A, generate 10 prompt variations for ordering one Metallica t-shirt size S for an e-commerce chatbot. Then test which variation gets the clearest, most reliable response from your chatbot, Model B.
That's clever. Saves a lot of manual tinkering. Now what about code? LLMs are good at language, but code prompting.
They're surprisingly good at code. They can generate code in almost any language. Need a quick bash script to rename files? Just ask.
Like adding draft to file names.
Yep. Prompt it clearly and it'll spit out the script. But big caveat, always read and test any code an LLM generates before running it. Seriously.
Good warning. And it can explain code too, and translate.
Absolutely. Take that bash script, strip out comments, ask the LM to explain it line by line. It'll do a great job. Need it in Python instead. Ask it to translate. It'll often even explain why Python might be better, like for adding a GY later.
Okay, but the real test, debugging. Can it actually fix broken code?
This is where it often shines. Say you have Python code with a common error, like using to uppercase instead of .uppercase. It's a name error. You feed the broken code and the error message to the LLM and ask it to debug. Not only will it likely spot the name error and suggest .upper, but the really good models often go further. They might suggest improvements. Hey, you should probably keep the file extension. Or what about handling file names with spaces? Or use f-strings here for cleaner code. Or even add try.ack, except blocks for error handling.
Wow, like getting an instant code review?
Pretty much. It's an incredibly powerful assistant for developers.
Okay, and just briefly, multimodal prompting. That's different.
Yeah, that's using more than just text as input. Feeding images, audio, maybe even video, along with text prompts to guide the model is a whole other advanced area, combining different data types.
Got it. So let's wrap up with some universal best practices. The things everyone doing prompt engineering should keep in mind. What's number one again?
Provide examples. Cannot stress this enough. One shot, few shot showing is often better than just telling. It guides accuracy, style, tone, everything.
And keep it simple.
Yes, design with simplicity. Clear, concise prompts. Avoid jargon if you can. Use strong action verbs. Act, analyze, generate, summarize. Easy for you to write, easy for the model to follow.
Be specific about what you want back.
Absolutely. Be specific about output. Don't just say write a blog post. Say generate a 3-paragraph blog post, informative and engaging conversational style. Tell it the format, length, tone.
And tell it what to do, not just what not to do.
Generally, yes. Use instructions over constraints. Focus on positive instructions, write in formal tone. Rather than negative ones, don't use slang. It's usually clearer and gives the model more flexibility. Constraints are still useful sometimes, like for safety or very strict formatting, but start with instructions.
What about length control?
Control max token length, either in the configuration settings we talked about earlier or right in the prompt. Explain quantum physics in under 100 words or in a tweet-length message.
And using variables.
It's super useful for making prompts reusable, especially in applications. Use variables. Define city Amsterdam somewhere, then use tell me a fact about city in your prompt template. Saves tons of time.
Keep experimenting too, right? Different phrasings.
Definitely. Experiment with input formats and writing styles. A question might work better than a statement sometimes, or vice versa. And for few shot classification, mix up the order of classes in your examples. Don't always show positive then negative. Mix it up to prevent the model just learning the order. Maybe start with 6 or so examples.
And stay up to date.
Crucial. Adapt to model updates. New versions come out, models change. Your prompts might need tweaking to work best with the latest features or architectures.
What about output formats for, say, data extraction? You mentioned JSON.
Right. For non-creative tasks, experiment with structured formats like JSON or maybe XML. XML is another tag-based format, a bit older than JSON but still used. JSON is generally great. Consistent style, forces focus on data, reduces hallucinations, handles data types.
But it can get cut off.
Yeah, if you hit your token limit, you might get incomplete JSON. But there are tools, like the JSON repair library, that can often fix truncated or slightly malformed JSON automatically. Super helpful.
And using schemas, like a blueprint.
Exactly. Working with schemas, especially JSON schema, is great for structured input. You tell the LLM exactly what data fields and types you expect. Example, product name is text, price is number, release date is date. This helps it focus, especially with complex data.
Okay, final advice. Collaboration and documentation.
Yes. Collaborate. Talk to others, see what prompts they're using. Different attempts yield different results. You learn faster together. And please, document everything.
Everything.
Everything. Your goal, the model, the settings, temp tokens, top KP, the exact prompt, the output you got. Was it good? Token is okay. Any feedback or ideas for next time? Use a template. Save prompts in your code repos. Use automated tests if you can. It's iterative. Craft, test, analyze, refine. That's the loop.
Wow. Okay. That was a seriously deep dive. From how LLMs just predict tokens all the way to these advanced techniques like React and Tree of Thoughts. We covered a ton.
Yeah, it's a lot.
It really feels like prompt engineering isn't just technical, it's almost an art, you know? A conversation.
I like that. It really is. We saw how just tweaking words, adding examples, adjusting those configuration dials, it can completely change what the AI gives you, from classifying an email to debugging code. And like you said, it's iterative. You're always experimenting, always refining.
And just remembering to tell it, let's think step by step, can unlock so much. That's still blowing my mind a little.
Pretty cool stuff.
So this brings us to a final thought for you listening.
When given all this movie, we've talked about guiding AI with precise instructions, structured thinking, using examples. What's one really complex problem, maybe in your work, maybe just in life, that you're now thinking, I wonder if I could tackle that with a really well-engineered prompt?